We're going to take a look at different ways to prove that triangles are congruent. So there are six parts to any triangle, right? Three sides and three angles. And depending on knowledge of those parts being congruent, we can say that the entire triangle, all of the parts, are congruent. So we're going to have four postulates here that we're going to look at. The first one is the SSS postulate, also known as side, side, side. All right, so what this states is that if all three pairs of corresponding, so we've seen that word before, corresponding sides of two triangles are congruent, then the triangles are congruent. So that means that we can assume the angles are congruent as well. Um, so if we're looking at these three triangles, they're all going to be congruent to each other, right? So they have one side congruent, which we marked with that one single tick mark. Then they have a second side congruent, which we marked with the double tick mark, and then a third side congruent, which we marked with the triple tick mark. Typically, we're only going to be talking about two triangles at once, but here we have three. So just like when we were doing CP/CTC, we can talk about the congruency statements, but it is very important to adhere to the CP/CTC rules. And when we write these congruency statements, our corresponding parts need to align. So if I'm talking about triangle ABC, and I want to say it's congruent to another triangle, I need to pay attention to how I'm moving around the triangle. So I go from A to B, so across the single ticked side towards the dual tick side, and then B to C, so across the dual tick side, and then back across that triple tick. So, oops. So then when I talk about being congruent to another triangle, I need to be consistent with that movement so that when I read the congruency statement will tell me just as much information about the congruent pieces as the picture with the congruency marks will. So let's try to say that this first triangle is congruent to this second triangle. So I want to start by going across the single tick mark side towards the double tick mark side, just like I did in that first triangle, and then across the triple. So single to double to triple. So I would say ABC, triangle ABC, is congruent to triangle RTX. And this is important to do because we need to make sure that these letters, which represent the angles, are appropriately representing the congruent angles. So if A and R are in the first spot of our congruency statement, then A and R need to be the angles that are congruent to each other. And those are the angles that are kind of made up by the single and the triple tick mark side. So we have to be very, very particular about that here. So let's try another one. Let's try to say if angle A or triangle 1 is congruent to triangle 3 here. So if we were doing this, we'd follow the same pattern. So across the single, followed by across the double, followed by across the triple. So we would have it congruent to triangle PYD. So now we can assume that angle A, angle R, and angle P are all congruent. B, T, and Y are all congruent, and C, X, and D are all congruent. So the first position, the second position, and the third position in our congruency statements. All right. So we can go about doing that another way as well. It all depends on how we name that first triangle, right? So if I am talking about the triangle YPD, so I started at Y, I went across to P, then to D, then back to Y. When I say it's congruent to say the second triangle here, I again need to be very careful. So I need to go across the single tick mark towards dual tick or the triple tick mark, and then follow that pattern. So I'd need to say this is triangle TRX. We could also do that another way by looking at what Y is congruent to. So Y, based on the other congruency statements, is congruent to T, right? We can see that it's in the second position of these other congruency statements. P is congruent to R, so we would put that in the second spot. D is congruent to X. So there's a couple different ways to do that if you have existing congruency statements. But what this boils down to is if 3 sides of the triangle are congruent, then all the parts of the triangles are congruent. All right, so our next one is the side angle side postulate. So order absolutely matters. This is side, angle, side. Okay, so this states if 2 sides and the, here's the important part, included angle of one triangle are congruent to 2 sides and the included angle of this another triangle, then the 2 triangles are congruent. So what's really important here is that the angle is the angle in between those 2 sides. So if I have 2 sides congruent, and then the angle that is included in between those is congruent. That is an example of our side angle side. So you almost want to think about if you're starting from kind of one of the vertexes, if you trace it, you're going to hit a side, then an angle, then a side. Okay, if you don't hit them in that order, then it's a different situation. Okay. So another example of this would be perhaps if we knew this angle down here, and then the 2 sides that are kind of sandwiched to make that angle there. So that's an example of our side angle side postulate. All right, next one. So here we have angle side angle, angle side angle. So this time, instead of an included angle, we have an included side. So now if there's 2 angles, an included side of one triangle are congruent to 2 angles, and the included side, so again, that's very important, of another triangle, then the 2 triangles are congruent. So here we have 2 angles, right? 2 angles, and the included side, or the side in between. So order is very, very particular in this topic, just like it was with CP/CTC. So if we wanted to write this triangle congruency, we might say that triangle APT is congruent, and again, we have to be very careful. So if we started with A and we went across from the single tick mark angle towards the double tick mark angle P, when we write it, we have to do the same thing with the triangle and go H, B, W, so that we're keeping up with our CP/CTC rules. Okay, so our last postulate is going to be the angle-angle-side theorem. Okay, angle-angle-side theorem. So this is where if we have 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle, then the 2 triangles are congruent. So what does this look like? So this is sort of if they're in sort of one right after the other. So we have an angle, we're going to skip that side in between, and then we have the side following. So angle, angle, side. Okay, so those are our 4 triangle congruencies here that work for any triangle. There are a couple other combinations of angles and sides, but they do not give us enough information to prove. So while there is an angle-angle-side theorem, there is no side-side angle theorem. And one way that's helpful to remember that is if you use your imagination a little bit and rearrange those letters, it probably spells something that you wouldn't ever want to write down on a math test. So if that ever happens, recheck your work. It's probably something that shouldn't have happened. So anytime we prove a triangle congruent, we're always going to need 3 conclusions before we can prove them congruent, right? All of these triangle congruency postulates have 3 pieces to them, talking about sides and angles. What we're going to do next is actually go ahead and prove some things. We're going to prove that 2 triangles are congruent using these postulates. So just as a reminder, we are going to be using the reflexive property quite a bit. So that states that a side AB is congruent to itself. So it feels like kind of an obvious postulate, but proof writing is all about kind of writing down the obvious, because we're trying to get from point A to point D, and everywhere in between, and giving no one any leeway to question us. So just like that works for sides, that also works for angles. Angle X is congruent to itself. Okay, so in proofwriting, we do write down the obvious, and it's because proofwriting is a very exacting process, where we put everything down that we could possibly think of, that we need. So when we're writing a proof, we're just going to be doing a basic kind of simple 2-column proof, and we're going to be using statements and reasons. So on the left, we're going to write our statements, right? We're going to say something about the figure. And then on the right, we're going to say, why are we allowed to assume that? Okay, why do we know that? What tells us? So in proofs, we always start with a given. So our first statement is always going to be, what do we know? Okay, well, we said that AC is perpendicular to BD. Okay, and then angle B is congruent to angle D. And our reason for that is that we were given that information. Now, proofs, we do need an end, and our end goal here is to prove that triangle BCA, so BCA, this kind of left triangle here, is congruent to triangle DCA, this sort of right triangle over here. So we're going to do that using one of our congruency theorems, and I'm going to try to decide which one I'm going to use first, to try to guide where my proof is going, because I'm going to need to try to put some information in this proof. So first I'm going to mark what we know. So if AC is perpendicular to BD, right? So we know that, and then that's going to tell us something. So that tells us that we have 2 right angles right here. So I'm putting in green the things that we are kind of saying that we know that wasn't technically part of our given, right? The fact that those are right angles wasn't part of our given. It's just something that we know because of something else we were given. Okay, so I know that. Angle B is congruent to angle D. That one we were just straight up given, so I'm going to stick that on there. And now I want to kind of figure out which of my postulates is going to be best to use here. So in this case, what I'm going to do is I'm going to put on here another mark. I'm going to say, okay, well, they share a side. They share that side there, which means that that side is going to be the same length in each triangle. So if I'm looking at this, it looks like I have an angle, and then a side, which is in fact one of our triangle congruency postulates. So what I need to do is, in my proof, those little green parts there, I need to actually prove that that's true. I need to say, why do I know that? So let's go ahead and do that. Okay, so second part here. So now I'm going to take a moment to state that those are right triangles. So I'm going to say, okay, well, angle ACB and angle ACD are right angles. They're right angles. And how do I know that? Well, I know that because the definition of a perpendicular bisector, right? I know that because AC, not perpendicular bisector, excuse me, definition of just perpendicular. We don't have a perpendicular bisector here. Okay, so I know that because AC is perpendicular to BD, right? Perpendicular means intersecting at a right angle. So I know that. Okay. But what I really want to say is that those angles are congruent to each other, right? Because that is what I need for my angle side postulate. I need to know that 2 sets of angles and their non-included side are congruent. So now I'm going to do something that feels very obvious but is necessary for the proof. I'm going to say that angle ACB is congruent to angle ACD. Well, why? Because right angles are congruent, right? If they're both right angles, then clearly they're congruent because they have the same measurement. Okay, so I've kind of, in my figure, taken care of a couple of pieces, right? So our first angle was good because it was straight up given to us. I've now proven in my proof that the right angles are congruent. So I need to work on this shared side, and this is where our reflexive property is going to come into play, okay? Fourth part, I'm going to say, okay, well, AC is congruent to itself by the reflexive property. Okay. So now, in my proof, I have definitively that I have two angles and a non-included side congruent to each other. So I can finish this off by stating my triangle congruency, and be careful, follow CPCTC. So BCA is congruent. Now, if I went from the single tick mark to the right, I need to do the same thing. So DCA, triangle DCA. Why? Because of the angle side postulate. Okay. So let's do another one here. All right. So again, we're given a little bit of information. I'm going to put it on the figure here, and then we're going to go from there. So we're given that RS is parallel to YP. So we have some parallel here. That could help us. And T is the midpoint of RP. So this is a midpoint. So I'm going to go ahead and just fill in some things that I know just off this figure. So they're not things I'm told, they're things I'm going to infer from what I was told. And again, I'm going to put these on my figure in a different color because these are things that we don't technically know. We haven't proved that they're true. They're just things that, because I know other stuff, I know these. So if T is a midpoint, then I know that the segments there on either side are going to be congruent. Okay. If I have two parallel lines here, then I know I can use information about transversals. And I can say that this is really a transversal right here, which means that alternate interior angles are congruent. Okay, so I have a little bit of information there. Okay, so let me get rid of some of these marks. Okay, and then we need to add a little bit more information. And what I'm going to add is that I see a pair of vertical angles right here. Okay, so that's all I can deduce about this or infer about this figure from what I was given. So I have an angle. Oh, I think I put my congruency markers on the wrong, oops, on the wrong one here, because T is the midpoint of RP, not ST. Okay, so sorry about that. My congruency markers belong there. Okay, so we have an angle, an included side, and another angle. So we do have an angle side angle postulate, which can be used to prove triangles congruent. So basically what I need to do is, in this proof, I need to take all those green parts that I drew and give justification for why I'm allowed to put those congruencies on there. Okay, so we are going to start with our given that RS is parallel to YP and that T is the midpoint of RP. And we're going to use that information later in the proof. So let's keep going. Let's keep proving these things, showing why we know it. So I want to go ahead and deal with my sides first. So because T is a midpoint, we knew some things. We could mark some things on the figure. Namely, what that was is that RT was congruent to TP. Okay, RT was congruent to TP. And actually, I'm going to rewrite that. I'm going to write that as PT. And why did we know that? Well, that's the definition of a midpoint, right? We knew that because T is a midpoint. So we knew that because of the definition of a midpoint. Okay, well, what else did I know on here? Okay, I knew that angle RTS was congruent to angle PTY because that's the definition, that's the vertical angle theorem. So that's the vertical angle theorem. We know if we have vertical angles, then their angles are congruent. So great. Okay. So I know that our final proof kind of says something not about the triangles being congruent, but we need to know that the triangles are congruent to know that all the pieces are congruent. So we're working towards that triangle congruency, and then we'll go from there. Okay, so the last thing I knew was that angle SRT was congruent to angle YPT, and I knew that, right, because of the alternate interior angles theorem. That should be the vertical angles theorem. That should be plural there. Alternate interior angles theorem, which tells us that alternate interior angles are congruent. So now I have my three pieces of the puzzle to go ahead and say, paying attention to CPCTC, that triangle RTS is congruent to triangle PTS. And we can say that because of the angle side angle theorem. But that's not the final stopping point because we need to prove that YT is congruent to ST. Well, the nice thing about proving that the triangles are congruent is that now every corresponding piece in the triangles are congruent. So if the triangles are congruent, then CPCTC, their corresponding parts are congruent. So 6, we can say YT is congruent to ST because of CPCTC, or corresponding parts of congruent triangles are congruent. And we can look in our congruency statement, and we can go ahead and fix something that I wrote here where this S should be a Y. Oops, I'm getting confused with all my letters, sorry. This S should be a Y, so I'll highlight that. And we can say, okay, Y and S are in the same place, good. And then T and T are also in the same place, so that's where we're getting that CPCTC from. So just as a summary, our 4 main triangle congruencies, side, 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 that's all 3 sides. Side angle side, that's a side, an included angle, and then another side. Okay, and then angle side angle, that's an angle, an included side, and another angle. So an angle, an included side, and another angle. And then angle angle side is 2 angles and a non-included side. So those are the 4 congruencies that we're going to be using, and we're using them to prove various things about triangles.